Hi everyone. So we covered rearranging Soka-Toa, didn't we, in the previous sessions? Soka-Toa. This session we're going to be looking at angles, angle sizes, which we didn't do before. Now here's what I wanted to just emphasize is that here's maybe how you can remember which formulae to do. So so opposite equals hype sine angle. Adjacent equals hype cos angle. Opposite equals to adjacent tan of the angle. Okay, I'm just showing you a quick tricks. And we can say hypotenuse equals opposite over sine A. Hypotenuse equals to adjacent over cos A. And then adjacent equals to opposite over tan A. So one side you have the divide, multiply, and the other side you have divide. So you might, you can memorize these if you want, or you can just rearrange the formula. It's up to you. So you've got multiply here and divide. Hypotenuse is always divide. So let's have a look at how to find the angle. If I told you that sine A is equal to 3/5, how would we know what A is? Well, we have to think about what an inverse function is. Any idea? Well, we have to know what that means. Any ideas what that means? What does inverse mean? It means opposite. So you've heard of inverse operation. Inverse operations are the inverse operation to plus is minus. The inverse operation to multiply is divide. And it's the same with inverse functions. They do the opposite to what you tell them to. So if I did 3x, that's the inverse function to x over 3, because I'm doing multiply here and divide here. In the same way, we need to use inverse functions to find out what this value here is. So if I told you that sine A equals 3/5, what sine is telling me is if I have the opposite over hypotenuse, if I have the angle, and I'm putting it into sine, it's telling me what is opposite over hypotenuse. Okay, but if I know my opposite over hypotenuse, how am I going to get back to my angle? And that's what we use the inverse of sine, or it's called sine. This is called sine inverse. I sometimes call it sine minus 1, just to help me remember. So sine, this is not the same as to the power, not x to the power of minus 1, okay? It means something different. Okay? Now let's see how this applies. So we're asked to find a value of angle A. So we have angle A, we have opposite, and we have the hypotenuse. Actually, yeah, so I've told you that sine 30 degrees is equal to opposite over hypotenuse is equal to 10 over 20 equals a half. So what's sine, how do we find out? So we can say that sine inverse of a half is the same as 30 degrees. So in other words, it's telling me if I know my opposite over hypotenuse, what is the angle? And what is the angle? Okay? Or we can remember it. So I guess you could say in this case the angle is sine minus 1 opposite over hypotenuse. Okay? Now let's look here. So if you can see, I've got my sine here. And to get to sine minus 1, you press shift and sine. So maybe, check your calculators. If you know that your calculator's working when you press sine minus 1, a half, and you're getting exactly 30. If not, then there's an issue. Let's look at another one. So this time I'm going to ask you to find out angle A. Right, so we label our sides. This is going to be our adjacent side, and that's going to be our hypotenuse. So then what do we do? Well, what ratio does that correspond to? Ca. So I know that cos of angle equals to 15 over 20. So therefore angle is equal to cos inverse 15 over 20. And what does that give us? Well, if I type that into my calculator, let me see what I get. 15 over 20, and I get 41.4 degrees. And that's my answer. So it's cos inverse adjacent over hypotenuse. Very simple. Let's try angle C. So, okay, no, we did that one, didn't we? Angle C, again, if I have angle C, it's going to be opposite over hypotenuse. So again, we have sine. So it's sine C is equal to 15 over 20. So C is equal to sine inverse 15 over 20. What do we get this time? So we had 41.4 4 degrees here. And what do we, I dropped my calculator. I know, almost. I caught it. We get 48.6 to 1 dp. And we know that's correct because 48.6 plus 41.4 adds up to, you guessed it, 90 degrees. Boom. So we know we've done it correctly. Let's try another one. So let's try, instead of angle C, I'm going to switch things up and make it a bit more difficult. Let's try angle A. It's this angle here. Now, what's the ratio? Well, we've got adjacent here. We've got opposite. I think we're in need of some tan love. So we're going to say tan A is equal to opposite over adjacent, or is equal to 10 over 20. So students might make a mistake and put adjacent over opposite instead. So make sure you're doing it the right way. I'm going to simplify that down. 10 over 20 is the same as a half, so equals a half, so there's that. So if we've got tan A is equal to a half, again, what do? We do A is equal to tan inverse, or tan minus 1 as I like to call it, a half. What does that give us? (26.6 degrees). So I've got 26.6 degrees here, or tan inverse a half. What do you think this one's going to be? here's how. It's just going to be tan inverse 20 over 10, because that's the opposite this time, and that's the adjacent. So we actually get tan inverse 20 over 10 equals tan inverse 2. So going off on a tangent, if I have tan inverse opposite over adjacent plus tan inverse adjacent over opposite, what does that give me? Well, these two it's going to give me 90 degrees. Okay, now I can prove that because tan inverse 2 equals 63.4, and if I add these two together they get up to give me 90 degrees. So there we go, that's it. That's all there is to it. So I'm just going to put my here. So angle equals sine inverse opposite over hypotenuse. Angle equals to cos inverse, which is the same as cos inverse adjacent over hypotenuse, which is the same as tan inverse adjacent over opposite over adjacent. So basically what we have are 9 formulae that we can possibly, you can memorize them if you want and you'll get the hang of them even without or you can just start, I'd say start off with rearranging it first and then getting to these. Don't understand where the rules come from, don't memorize the rules just for the sake of it, but I just thought I'd give you some quick tricks. Great, thanks everybody, have a nice future, take care, go on,